Can you solve this geometry challenge? Here's the question. Given this triangle ABC, now point D is on side BC and point E is on side AB. Now the intersection of AD and AE, let's call this as F. Now the area of this quadrilateral BEFD is given as 78 square centimeters, and also given that the ratio of AF to FD is 3:1 and the ratio of EF to FC is 2:1. The question, what is the area of the triangle ABC? Now pause this video right now and see if you can answer this question, because I will show you the answer and the solution in 3, 2, 1. Alright, the answer to this question, the total area of this triangle simply equal to 108 square centimeters. And of course, the question is, how do we get this answer? And here's our solution. In order to solve this kind of question, we have a lot of methods, but what I like to do is this method. This is called the mass point geometry. And here's the figure that represents the mass point geometry. In this technique, we will assign weights or masses to the vertices in this figure. And also, in this kind of solution, we combine physics and geometry, specifically applying the principle of lever to find the ratio of the line segment within a triangle. Now, for example, in this figure, the mass of point P is 9 kg and the mass of point R is 5 kg. Therefore, this point D is the combined mass of point P and R, which is 5 plus 9 equals to 14. And also, this tells us the ratio of TR to PT, which is 9:5, and so on and so forth. So given the ratio of AF to FD, we know this is 3:1. Also, EF to FC, this is 2:1. Now, the problem with this is 2 plus 1, the mass of these two. If we combine this is 3, and the mass of 3 to 1, the mass is 4. And now, the problem is, we need to have the same mass of this vertex F, like in this vertex X. 6 plus 14 is 20, and 11 plus 9 is also 20. And of course, we have the solution in that specific problem. The possible mass of this vertex F is the LCM of the sum of 2 and 1 and 3 and 1, which is 3 and 4. And the LCM of 3 and 4 is 12. Now, in order to have a sum of 12, we will focus on this ratio AF to FD and EF to FC. Now, here's a technique. 2 plus 1 is 3. Now, multiply 3 to 1 by 3. So, this ratio becomes 9:3. And take note, 9 plus 3 will give us 12. Now, how about this 2:1? So, we add 3 plus 1 is 4. Then, multiply to 2:1. This is 8:4. And again, 8 plus 4 is 12. In short, we can replace this 3:1 as 9:3. And this 2:1 as 8:4. Still 2:1. Now, the mass of this vertex F simply equal to 8 plus 4 and 9 plus 3, which is 12. And now from here, we can now get the mass of each vertices. For example, this vertex E, this is just 4. And this vertex C, this is just 8. Also, this vertex A is just 3. And the mass of point D is 9. Now, the combined mass of D and C is D, which is 9. In short, the mass of B must be equal to 1. And that is okay on the other side, because 1 plus 3 will give us 4. And now from here, we can now get the ratio of DC to BD. DC must be 1 and BD must be equal to 8. And also, we can get the ratio of EA to EB. EA must be 1 and EB must be equal to 3. Now, let's focus on this diagram and its ratio, of course. And also take note that the area of this quadrilateral BEFD equals 78 square centimeters. Now, to get the area of the whole triangle ABC, let's connect first B and F like this. And let's call this triangle, the area of this triangle, be equal to X. Since the total area of this quadrilateral is 78, this triangle EBF is simply equal to 78 minus X. Now, we will use another concept, and this is the ratio of areas. This tells us when we have two triangles having the same height, therefore, the ratio of their areas must be equal to the ratio of their bases. So now, let's focus on these two triangles, the blue and the green. They have the same height for sure, and the ratio of their bases is 1:3. Therefore, the area of this blue triangle is 3 times the area of this green triangle. In short, the area of this green triangle must be equal to 78 minus x divided by 3. And now, we will use again this concept in these two triangles. These two triangles have the same height for sure, and the ratio of their bases is 9:3 or 3:1. In short, the area of this blue triangle is 3 times the area of this green triangle. So we can get an equation like 78 minus x plus 78 minus x over 3, the blue triangle, equals 3 times the area of this green, which is x. Now we can now solve for the value of x. Solving this, we get that the value of x simply equal to 24 square centimeters. So that is the area of this triangle BFD. We know x, 24 square centimeters. In short, 78 minus x is simply equal to 54 square centimeters. And 78 minus x over 3 for triangle EFA simply equal to 18 square centimeters. Now, we know the area of these three triangles. Now, we will use again one last time the ratio of areas in this triangle. This time, the ratio of their bases is 1:8. In short, the area of this blue triangle is 8 times the area of this green triangle. Now, what is the total area of this blue triangle? This is just 96 square centimeters. So the total area of this blue is 96 square centimeters. Now, we know that the area of this blue is 8 times the area of this green. So 96 divided by 8 will give us 12, and that is the total area of this green triangle. In short, the total area of triangle ABC is 96 plus 12, or simply equal to 108 squares centimeters. And that is our answer to this question. Therefore, given this figure, then the area of triangle ABC simply equal to 108 square centimeters. And as always, we are done.